questions afterwards as well, if there's any specific questions that we still need to sort out about the exam. We can look at that. Okay, so let's go into the mock exam and just look at certain of the questions. So if we look at and this is a very good view of how it will look like in the exam as well. So nearly first set of questions, and I think this is just one of those things again that you need to keep in mind. It is study unit 1 or 2 questions, study unit 2 1 or 2 questions, study unit 3. So because it is open book as well, just try to nearly get yourself ready for and if you have a printed copy, put stickers in that you nearly for every chapter have the sticker that you can quickly go to it if you need to get to the study guide or to the handbook, just so that you don't waste too much time because of the open book. So just nearly on that. So let's quickly look at this one. Let's highlight a few things. So the majority of rural schools in South Africa, in the Eastern Cape, KZN, Limpopo, so they talk about the 3 provinces. The Department of Basic Education requires assistance in gathering some of the information. Scholarly transport system. Which one of the following statement is correct in regard with types or type of variables? Okay, so the list of schools requiring learner transport is qualitative ordinal variables. So just already by ordinal, we know it's incorrect because there's no order going to be in the list of schools. So that already one can see is incorrect. And the second one, the distance from a learner's home to school is quantitative, right? Discrete, not right. It is continuous. So that one is the one that is incorrect because it is continuous. So let's look at the third one. The number of learners at each school is quantitative. That's correct. But the number of is discrete. Okay, so they've swapped those two around. So the number of learners is quantitative, yes, but it is discrete. Then travel time is very much like distance. So it will be quantitative, yes, but again, continuous. Then the level of schools, primary, junior, high. So there is rank in that. So it should be ordinal. And then because it's ordinal, it should be qualitative and not quantitative. So E will be the correct one. Okay, so nearly in this process, also it's sometimes easier than just to to work through the question so that you nearly get to eliminate and see which one is the correct one. So that first one was types of variables. So that is chapter 1. Okay, so that is just part of how it was drawn. Okay, so then, and this is also something that you guys, please, if something like this happens in your exam, so what happened previously when there was this big data set, it was sometimes on certain computers, it did not show the whole data set. So if something like that happens with you guys on Saturday, again, just after the exam, let me know and say, question 2, it said there are 50 numbers or selected households, but I could only see 35 or something like that. So if that happens, just please let me know so that we make sure that you guys are not penalized because of some of the things not being able to see or something like that. So you can see all the wording was up until here. So if something like that happens where a piece of data is cut off, please just again let me know, then we can mark it at the lecture. So with x as the lower class limit of a fourth, what is the relative frequency of class x to 38? Wait, let's just the data below question random. Use 15 as the lower class limit of the first class to construct a histogram of daily. Okay, so 15 is the lowest. Let's just check. So it seems like all of these are ordered. Okay, so then we would say they want 6 classes. So okay, don't say which one is the highest. So we probably would have said okay, so how would you have selected that? I would have now said 46 minus 15 because they don't tell us 46 minus 15 divided by 6. So I would nearly have 5 in a class. So let's just see if they say anything. No. So how many did you have in a class? Did you also say 46 minus 15 or 50 minus 15? So I would have said 46 minus 15. And then that gives us
So I'm lost. What do they mean by relative frequency?
okay, so repeat that quickly.
So I'm lost. What do they mean from this data set? Because I tried to analyze this data thing. While I was looking at the exam prep, there was a similar question, but still I'm lost. So why do they
Okay.
do they do 0.36 in the similar one, but now they say 0.28?
See,
I
so
don't know how it gets
what
solved.
need what we need to do is we need to nearly create, and I'm now just gonna do this. Let's just, so we need to create the bands of each one. So 15 to, let's say 20. I just first want to check it out. 21 to 26, 27 to around 52, 53 to 58, 59 to, what is that, 44, then 45 to 50. Let's see if that is 6 classes. 1, 2, 3, 4, 5, 6. So basically what we need to work out is how many numbers are falling in that 33 to 38 class. So where's 53? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 out of the 50 is falling in that band. So what is the relative frequency of that is 14 divided by 50. That would give us 0.28. Okay, so that is how we will do that. If I ask us cumulative frequency, then we would have needed to work out up until this one. So then it would have been 1, 2, 3 for that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or we could have just gone the other way around, but that's fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so if it was cumulative frequency, then we would have added the 3 plus the 12 plus the 18 plus the 14, and that divided by 50 would have given us 0.94. So that is if we wanted the cumulative frequency. Okay, so that is just different things that they can ask. So they give us the bottom one so that we can say 46 minus 15, and that we need to divide by how many classes there are, which is 6. So 46 minus 15 divided by 6 is just more than 5. So we will then add 5 to the bottom. So 5 to 20, 21 to 26, 27 to 52, and so forth to get all of those classes. Okay, so that is how we would do this, but just also then remember the cumulative one, because that can be maybe one that they ask next, because this has been now in one or two mock exams examples as well. Yeah, so you need to get nearly an anchor for that first one. So if I don't give you the anchor for that first one, you go for 16. So if I don't give you 15, you use the last or that first number as your lowest one. So that's why I looked at if there was maybe an upper one as well, and I nearly guessed it would have been 50, but they nearly want you to anchor. Otherwise, you start with 16, but then it will be 16 to 21, and then it does become very confusing. Exactly. So that is why, because if you used 16, it will move up by one. So then this would have been 34 to something else. So you would have actually then seen that it would not go to 33 to 38, but then it would have been going to 59 or even another different number. So that's why they need to anchor it. Else, we would have, well, I would have started at 16, because if you don't anchor me at 15, I will start at the smallest. And then it would have been 16 to 21, 22 to 27, then it is 28. So then it really becomes out of line. And then you would have seen that this one was probably going to be not 38, but 39 or 40, and then it also become confusing. So they need to at least give you some point to start off with, because else you can start with anything. Yeah.
I see, I understand now. Because
Okay.
while I was trying to do this thing, I did try and create the classrooms, but I was creating the classrooms in the wrong way. Thought I was adding six, but actually to from 15 to 20 is actually six elements. Then
Yes. So
21 to 26, and then they actually gave a hint there.
yeah. So
Oh,
I think that's also the thing. Just sometimes they tell you in the question the number of classes there are. Sometimes they tell you the width of each class. So just be careful when, because they do mix it up. So just now be very careful in the exam that they don't use very similar, but instead now of the 6 classes, they say class width is 6. Okay, so then it is just the other way around, that you will probably sit with a width of 6, but only 5 classes. So just be very careful for those things in the exam as well, that because what I have seen, and you guys have seen it now through all the assignments nearly, there are a lot of the things that are repeated, and then they change some of the numbers or just a bit of a question. So just be very careful that they might use some of these questions, and change it from correct to incorrect, or change it from the class with versus how many classes. Um, yeah, so just be on the lookout for those things. Okay, so let's just again, so something different again to some of our other questions that we had around um, quartiles and those kind of things. So consider sample of size 21. In an ordered array of these observations, which one of the following statements best describe how to determine the quartiles of the sample data? Yeah, this was the one that was shared on my UNISA as a PDF. Not, I don't think it was very similar to the mark that you are writing or have written in some of the question, but this is the one that is shared the PDF in on the my UNISA. Okay, so observations 21. First quartile is calculated as the average between observation 5 and 6. Let's see, what are we looking for? Which one of the following statements best describe how to determine quartiles of a data set? Okay, so first quartile is calculated as the average between observations 5 and 6. The third quartile is given by observation 17. The third quartile is calculated as the average between observation 17 and 18. The second quartile is calculated as the average between observation 11 and observation 12. The first quartile is given by observation 5. Okay, this is quite interesting. So how I would have worked it out, 21 plus n divided by 4. So that would have been 22 divided by 4. That's now for U1. So 22 divided by 4 is 5.5. Okay, cool. So that is the first quartile is calculated as the average between observations 5 and 6. Okay, because it's 5.5, that is correct. Let's just check. Q2 will be then 2 times 21 plus 1 divided by 4. So that's 21 plus 1. That's 22 divided by 4 is 5.5 times 2 is observation 11. So here was the second quartile is calculated as the average. So that's incorrect because it is calculated as 11. The first quartile, so that is incorrect because it's 5.5. And then you can just look at quartile 3. The 3 times 22 divided by 4. So 3 times 22 is 66 divided by 4 is 16.5. So quartile 3 needed to be between numbers 16 and 17 and not 17 and 18. Okay, and then that one is also wrong because it is 16.5. No, so the the mock exam does not have, so that's why I have shared this one again with you guys on the WhatsApp as well, that you have it. Also, the two exam papers that was still written last year, there's also answers in there as well for you. So you have now basically the last 2 years of exam papers that was written online. Okay, so let's quickly check this one. So again, so just to go back for this, we didn't need to use Excel. For this, you did not need to use Excel because, again, it's more theory based. So let's look at what they give us here. So a recruitment company collected data on starting salaries, give a data of 16 random graduates. Which one of the following statements about the empirical rule or the distribution of technology graduate starting salaries is correct? Hint, calculate the three measures of location to comment on your distribution and the standard deviation to comment on the empirical rule. Okay, so now this is not something, and there's no other information. So the first thing I would look at, and it is audit. So the first thing I would look at is median and mode. Because that tells me if those two are equal, then I will work out maybe the average, because then median, mode, and the mean is equal, then we know it is a symmetrical. So let's see, the median is the one in the middle. So there's 1, 2, 3, 4, 5, 6, 7, 8, and then there's 8 on the other side. So it's the one lying between 233 and 235. So that's 233 plus 235 divided by 2. So that would give us 234, and that is in thousand. So they don't talk about that. So let's just quickly see if we've got a mode. Any number. So that's first number that is happening twice. Okay, sorry, it was not ordered. Okay, that's not nice. I only pick up that one now. So that was not ordered. Okay, so we need to order the data first. So that again, sneaky, that one in there. So it should then move to that side. So let's just now see if that is taken out, if this now is ordered. So that was sneaky. So that small, larger. Okay, now it's ordered. Okay, so all that means is we will after the 8, so 1, 2, 3, 4, 5, 6, 7, 8. So this is actually where our median is. So it is 232.5. So let's, okay, so sneaky. It was, that will be your median. So the median is 232,500. The mode is 224. So already we see that the median and the mode is different. Okay, yeah. So this is good that we now see this mistake and that you don't do it in the exam as well, because everything was nicely ordered and then just that sneakily one. So already we can say that the data is going to be skewed. So the distribution of technology graduates starting salaries is positively skewed. Distribution salaries is negatively skewed. So with these two, we can already say there's going to be a skewness. So then we can check in, what is it, study unit 3. So study unit 3, what's it, study unit 3 or study unit 2? Let me just quickly see where I have.
Study unit 3.
Study unit 3, yes. So if your mode is smaller than your median, then it is positively skewed. We don't even need to work out the mean because that we know now already. The mode is smaller than your median. So that means it is positively skewed. Okay, so then already we can say that is going to be the answer. Then we can't, because the data is skewed, we can't assume a normal distribution. So then we don't even go into the standard deviation and the empirical rule because our data is already skewed. So now we can't say that there will be between two certain numbers, because that is what we do in study unit 6 and 7. And 8, remember, confidence intervals. So there we know something needs to be normally distributed. And if it's normally distributed, it falls within certain bands. So again, this one, you could have identified it at the start nearly that it is skewed positively. So again, you did not need to put this into Excel to work out the standard deviation because we already knew that the mode is smaller than the median. Okay, so again, but here it would not have made a difference in my calculation with the median. It would have still been, the mode would have still been smaller than the median, but still just be very mindful and look out for things that they might try to catch you. And this was definitely one of those, because you guys could have seen only when I went to the next step to look for the mode, I've picked up that one. Okay, so then again, we get data, lower limit. Can you guys remember the formula for that lower limit? Because that is not the same as Q1 and Q3. So remember, and let's put that in. Thank you. And it was definitely, let's see if I can copy and paste it in. Probably not. Okay, so let me write it down. This was also, I think, in your first assignment. And if it wasn't in the assignment of yours, it was definitely in some of the mock assignments and previous. So very important, Q1 minus 1.5 times the interquartile range. Okay, so, and it will be interesting to see exactly. So that is for one thing. When they need to say to you, you're working out quartile 1 or Q1. So all they need to tell you, you're working out quartile 3 or Q3. So there is also an upper limit where, and if somebody can just put the upper limit, I think it is Q3 minus that, but or Q3 plus. So just if somebody can put in, as I, so the upper limit is Q3 plus 1.5 IQR, interquartile range. So just be, so that is the lower and this is the upper. And it is different from what Q1 is and what Q3 is. So this one, actually, we needed to do a lot of work again, and maybe it was a mistake in the data, but that should have been something else. But again, that number should be there. So if we need to get Q1, let's first do Q1 is n plus 1 divided by 4. Q3 we also need to get, because we need to get to the interquartile range, is 3n plus 1 divided by 4. So that one, n they said was 16. So 16 plus 1 is 17. 17 divided by 4 is 4.25. So the closest one is 4. So it will be 1, 2, 3, 4. It's 2, 2, 1. Okay, so there you have the 2, 2, 1. So this is probably going to be 2, 7, 1, but let me just, so 16 plus 1 is 17 times 3 divided by 4. So we're looking at 12.75, which is number 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so there we have Q3, which is also here. So we want Q1, which is 221 minus 1.5 times the interquartile range, which is 271 minus 221, which is 50. So 221 minus 1.5 times 50 is 75. So that is equal to 146. Okay, which is option D. So there's also your 75, which is your interquartile range. That's your Q1. That's Q3. So that's your lower limit. And I won't be surprised if that is your upper limit. So let's quickly see 271. So that was 50 times 1.5 is 75 plus 271. So that is your upper limit. Oh, sorry, your interquartile range. Where's your interquartile range? Your 75 is the interquartile range times the 1.5. Okay, so phew, there's so many things in here that, so you've got the interquartile range, you've got Q1, you've got Q3, you've got that IQR times for 1.5, and you've got the upper limit and lower limit. Yes, I see two hands, so please ask.
Just want to clarify the formulas for the quartile calculation. It's n plus 1 divided by 4, not n minus 1 divided by 4. I think I made a mistake in the calculations.
Yeah, so Q1 is always 1, then in brackets n plus 1 divided by 4. Q2 is 2 times n plus 1. Sorry, that should be n plus 1 divided by 4. And then Q3. And then just remember that we round it off if there's decimals. So that would be rounded off to 4. And that would be rounded off to number 13 to get away from the decimals, because we're not going to work out what is 4,25 and what is 12,75. You guys don't need to work that out. Okay, there's another hand.
Hi, I just wanted to ask the value of n. How did we determine that?
Oh, the value of n was, in the previous one, they also gave it to us as 16. So all that you do is you just count how many there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there was 16 values. So that is how I got the value of n. But normally they will also tell you it. So because they told you in one of the previous questions, I just copied it from there. So that's how I got the value of n. Also, just be your exam, if I have it right, you can't go back to previous questions. So just make, and that again is a bit unfortunate. So here you would have needed to count the number of graduates again to get to the N16, because you couldn't go back to a previous question. Okay, so let's see. Okay, some theory question. Which measure of central tendency is most affected by outliers? Okay, so first measure of tendency, there's only 1, 2, 3. That one is not. So that one is not central tendency. That one is not. Okay, so mode is the number of how many times a number appears. So if there is outliers, it will not affect your mode unless there are a number of outliers, but then it will also not be outliers if your mode is the outliers. So mode not affected by outliers. median is always the middle value of your data set. So if your data set is looking like all the data is there, and here's one outlier somewhere, that will also not be affected because the outlier does not affect where the median, because median is always the number within your data set, or the middle number of your data set. So where it in central tendency effect is the mean. Okay, so, and that's, so in the other exam prep, it said your interquartile range. So where the mean, oh, okay, so that is quite interesting because also interquartile range, it will not affect interquartile range. Where it will have an impact is on your variance and your standard deviation, because you use the mean in your variance and your standard deviation. So if they were talking about the range, the variance, and those kind of things, where it will is your dispersion. So, but your dispersion, where it will have an impact is on your, because it has an impact on your mean, it flows through that it will have an impact on your standard deviation and variance. Interquartile range, again, if it depends on how many outliers you have, because your interquartile range, again, it's Q3 and Q1. So if your median is not affected, the chances of Q3 and Q1 being affected is also very small. So it's interesting, the interquartile range one. So yeah, the outliers will definitely have an effect on mean, and then it will have an effect on the measures in dispersion that are standard deviation and variance. Oh, okay. So which interquartile range? So let's quickly see what, so dispersion one. So range will be affected because range is your minimum and maximum. So if you look at the question that was now posted in the chat, outliers, what will affect for dispersion? So dispersion, so let's see, it will affect range because range is maximum minus minimum. So if you have an outlier, that will be your maximum. So then it will have an influence on your range. Or if it is on the other side, it will be your minimum. So then it will have an influence on your range. Where it also will have an influence on is variance, because remember, your variance calculation is the x minus the mean, and it has an impact on the mean. So variance, it will have an impact, and standard deviation, it will have an impact on. It will not have an impact on interquartile range because it does not have an impact on Q3 or Q1. But these three will definitely have a direct impact by outliers in the dispersion, because range, we know if it's to the one side minimum or to the other side maximum, it will have an impact on the range. And then it will always have on your, because it has an impact on your mean, it will have an impact on your standard deviation and your variance. And then probably, phew, what is that other one? The CV, the correlation, what's it, coefficient, what's the CV? The coefficient of variation, because coefficient of variation is standard deviation divided by mean. If that is then on a list, that will also have be impacted by outliers, because it will have a direct impact on both of them. Okay, if there was one that said on dispersion, it is quite a few that actually can be impacted in the dispersion. It's probably only the interquartile range that's not impacted. If I quickly look at everything that we mentioned, it's probably only the interquartile range that's not impacted. But it is a lot. So they will probably ask you which one is not affected, because so many are affected. Yeah, so it might be not affected would be your interquartile range, which is nearly the only one. All the others somehow has a link. Okay, then a bit of probabilities, and again, where sometimes they now have a different view. So sometimes we use the complement as that sign. So, and in some books it's AC, but let's see, consider two events, A and B. Probability of A is that, probability of B is that. A and B is equal to that. Which of the following statements is correct? Okay, so the first thing, when I see that, I know that it then is not mutually exclusive. So events A and B are mutually exclusive. That's incorrect, because if it's mutually exclusive, it needs to be equal to 0. Okay, so then complement of A is 1 minus 0.55. So complement of A is 0.45. Okay, so they just swap those two around. Complement of B yeah, so they just swapped those two around basically. Then I will work out the probability of A or B. So it is probability of A plus probability of B minus the and that will give us 0.66. That is correct. And if events A and B are independent, then probability of B given A is equal to probability of A and B. So it is probability of A and B is 0.11 divided by probability of A, and that should then actually have been equal to that. So it should be then probability of B. So let's see what this one comes up with, divided by that, 0.2. So we see that one is also incorrect. So the one that is correct is probability of A or B. Okay, so that was a nice probability one. So there's probably another probability, because then we need to get to a probability that is in a table. So we have this data. Given that a randomly selected individual feels a low level of being marginalized, what is the probability that they identify as that? So what is the probability of that given low? Okay, so I would basically have said okay. Okay, so that is interesting. So you got a partial right mark as well. Okay, so let's just see. So it is the proper. So I've now used it in this one. So it's the probability of cis and low divided by probability of low. So that is how we would have written it if we had probability A given B. We would have said its probability of A and B divided by probability of B. So probability of that is 0.76. And then the total of low, okay, is also 0.76. So that is equal to 1. Sure. Okay. That is an interesting question, because we will normally not see in a cross tabulation that you get the probability is equal to 1. So that means everybody that has a low level of feeling marginalized is falling in that category. That is okay. Yeah, so it's not that we always see the probability of 1. Okay, so also look at, there are some of these that are zeros. So that also mean that your non-binary and low, it's mutually exclusive because the and is 0. Transgender and low, mutually exclusive. Other and low, mutually exclusive. Non-binary and moderate, mutually exclusive because the and is 0. So just see all of these that are mutually exclusive because the and is 0. Okay, so just if you get something like this again, and they talk about mutually exclusivity, they can bring it in a question like this because where all those ands are zero. So they could have said non-binary and low is mutually exclusive. So just if they are something a bit different towards the other side of mutual exclusivity out of a table like this, just be cognizant of that. If there's in a table a zero, it means it is mutually exclusive. Okay, and this one I think we have seen as well. So suppose that x is a discrete random variable with n equal to 11 equally likely outcomes. What is the expected value of x? Okay, so how would we have done this? So each one would have been, you have your outcomes from, suppose that x is a discrete random variable with n is 11 equal likely outcomes. So all of them have that outcome. So sure. So this is, if you did not use Excel, what you need to say is 1 times that plus 2 times that, 3 times that, because that's from 1 to 11. And the outcome for each one is 1 out of 1 divided by 11. Yeah, so like you said in the chat, 1 times that plus 2 times that plus 3 times that. So again, it's possible to do it on a paper, but it's also easier to do it in Excel. Can we have used, see the formula for, and it's not, so if they told us it's binomial, then we would have used n times pi, or n times, which is then 11 times 1 over, so that would not have worked because then it would have been 1, so not binomial. So even if they said to us the binomial and you need to work out the mean, it would have given us something different. So yeah, unfortunately, need to work it out a bit or write it out a bit, but then the answer would be equal to 6. So there's a few that I would in any case have eliminated. So 1 over 11, it can't be because that is just the probability of each of them. So 10 or 11 might be, and it's interesting, we 11 over 2. I don't know how they would have gotten to that. So I would nearly have eliminated A and D, but then unfortunately you need to work this out to get to 6, 10, or 11. Okay, so if that was discrete, then probably the next one is binomial, and then the next one is Poisson. Okay, so binomial, consider the building inspector's visit again. Suppose now that 16 new built houses are selected at random. Remember that the inspector knows from past experience that 8 out of 10 new built houses complies with municipal regulation. What is the probability that only 5 of the 16 new built houses will comply with municipal regulation? Okay, so we have the formula in your study guide. So let's just first write out everything and then we can look at, so n is always the 16. Okay, so that n is 16. This is what the pi is. So that is the 8 divided by 10, which will give you 0,8. And then that will probably be the x that we're looking at. So let's just write the formula down because we will now need to use the formula for this one because they write it in the way of the formula. So there's not anything else we could now use for this. So let's just write it out a bit bigger. So then it's multiplied by that to the power of x, and then 1 minus that n minus x. So I would always look at these last two components first. So that is 0.8 and x is 5. So that is 0.8 times 5. Okay, that's all of them. So that's not going to help. The next one, 1 minus 0.8. So that's 0.2. And that's 16 minus 5. So that is 11. So let's see. Okay, so there's one of them, one of them, one of them. Okay, so not that or that at least, because that's to the power of 16. So now we need to check that first component. So n to the power or to factorial. So that is on your calculators, that is where the factorial. So 16 factorial, then it is divide by 5 factorial, then n minus x, so that is the same as that one, so it is 11 factorial. Okay, so that, let's see if my calculator has the power or the memory to do that. Okay, so it can get to 16 factorial, a weird number, but then I divide it by 5 factorial. So it still is a big number. So then I divide it by 11 factorial. And then my answer is 4368. Okay, so that you can do on your calculator. So n will always be bigger than the x. N must be bigger. So n is always bigger than the number that they are referring to. It can be the same. So it can be that they said, what is the probability that 16 of the 16? So it can be n and x can be the same value, but else n will always be bigger than the event itself. Okay, so you can't have it the other way around. So x will always be smaller or equal to n. Okay, so that way you nearly can't get it confused anymore, because n will always be bigger or equal to that number. Also, what I always found interesting is that there's nearly a repeat in certain parts. So the 4368, the 4368, the 33, the 33. So if I looked at this just pure, I would have said, okay, probably that one is also going to be incorrect, because they are not repeating that number. So most likely between those two, that we need to get an answer. Okay, so this was purely from the formula that is also nearly that first page or second page of your study unit 5, where they have the summary of the formula for binomial and the formula for Poisson, and that is only because they ask it for only 5. They're not going to ask this for 5, 6, 7, and 8, and you need to now put in 3 or 4 formulas. So it's only because it refers to 1x. Okay, so they will not ask you to do this for where x is equal to 5, 6, 7, or more than one x number, because then it really becomes nearly impossible, because then you have this one time, then you will have it for the other x, so then all these numbers change if you have another x. So if you had x as 5 and 6, now suddenly you need to repeat it for x6. Then all of these will change. That will change. That will change. So they won't ask it for you for more than one x number. Okay, so also important nearly is if I ask the binomial here, just remember that they can ask the Poisson as well. So the Poisson also have a formula that can be asked. So the Poisson one is the lambda to the power of x e to the power of minus lambda divided by the x factorial. So just now be nearly on the lookout that it might be that in the exam they rather ask the Poisson with a formula. Okay, so binomial, there is no mention of time. So when we have a binomial, it is basically the thing is happening or not. So 8 out of 10 times it's happening, 2 out of 10 times it's not happening, but there's no mention of time in binomial. When we go to Poisson, so yes, they tell us Poisson, but there needs to be some form of time. So now consider Poisson with the expected number of occurrences per interval. So that tells you it is happening a certain number of times. So they don't always need to tell you binomial that you're dealing with a binomial, because they will always tell you it is a number of outcomes and something like that. But Poisson, there will always be this per something. So per minutes, per interval, per time frame. So that is always the important one to look out for. So if I don't mention that it is per interval or per time, then we know it is the binomial. Okay, so here they tell us that per interval is equal to 4.3. So we know that the lambda is 4.3. But now they will go to that level of at least. So now you can't use that formula because you would have needed to do it for if it's at least 3, so that means 3 or more. So we're not going to do that for 3 or more. So that's where we will use the table. So let's quickly see if I can get to that table. So if we go to the table, now we need to go find Poisson. If Poisson, I said 4.3. Yes, 4.3, but now we need to go for 4.3. And let's quickly see. They said we need to have occurrences per interval at least 3. So it's 3 or more. So 3 or more. So that we need to add all of these ones together. So that will be the 3 or more, or I can say 1 minus 0, 1, and 2, because that will just be so much easier. So 0.0136 plus 0.583 plus 0.1254. So it is 1 minus 0.1973. And that will give us then 0.8027. Okay, so you can also add all of these together, and that will also give you the 0.8027. Let's just see if there is 0.827. So there's also the 1,1 or the 0.1973. So if we did the other component of saying it's less than 3, where is our number for less than 3? Yeah, so just again, be careful in how we read it, but no problem in you adding all of that together. You will also get the same answer. Okay, so let's look at another one. So we had something similar last night, but last night we needed to look between two Z points. So this one was basically where they said, given that the Z is standard normal distribution, what is the value of Z such that the area to the left, okay, so if that is 0, we know that this area is 0,5. So area to the left must be equal to 0,7190. Okay, so that means that we are sitting with a positive Z. So then automatically Not gonna work, not gonna work. So let's just cross it off in the, so that's not gonna work, that's not gonna work, that's not gonna work. Then I would have looked at this and say, okay, there's a negative, that's also positive, but okay, that's the only two that's left, so nothing that could help me now with a guess between those two. So we will need to go to the Z table. We can go to the positive table and look for 0.7190. So positive table 0.7190. So in here, 0.71. Oh, we used it for something else at some stage. 0.58. So positive 0.58. So at some stage in one of the examples or preps, we had something very similar that we needed to look at that. So 0.58 is our answer. Okay, so if it was that we looked at the right to it, and the right to it was 0.719, then it would have been the negative 0.58. Okay, so that is just nearly the difference. If we looked at the same size and we looked to the right of it, then it would have fallen like this or looked like this, and then we would have had the negative answer. Okay, so let's go into the next one. Okay, so here they give us a bit of information. Looks again like the one we did last night. So Department of Education found that learners' travel time from home normally distributed with a mean of that standard deviation. What is the probability that learners' travel time from home to school is more than 90 minutes? Okay, so if you get this, do we use a Z or a T? Okay, so okay, so let's quickly check. Are we still in? Okay, so the reason is that, so if you look at this, yes, we are in chapter 6, so that is one of the correct answers, but there is no mention of a sample. Okay, so there is no sample. So that is chapter 6. So there is no mention of a sample. So our formula will still be x minus this divided by, because there is no mention of a sample. They looked at one school. So if you said divided by 1, but they looked at one school. So that one school is the population. Okay, so there is no mention of the sample. Basically looked at the one school. That one school is the population. Okay, so exactly. So when we talk about sample, when we actually move into study unit 7, and that is when we are talking between the differences between Z and T. So that's why I just wanted nearly to ask it here, so that we nearly don't always get confused. And then if your standard deviation is unknown, you go for the T. Okay, so no mention here of sample. So then it is the normal Z. So let's see, when it is normally distributed with mean of 114, standard deviation, and then what's the probability that learners' travel time from home to school is more than 90? So 90 minus 114, sorry, divided by standard deviation is 72. And let's just write it in probability that Z, let's change it there. What's the probability that learners time from home to school is more than? Okay, so just that we put it in there as well. Okay, so let's see if this is so 90 minus 114 minus 24 divided by 72. Okay, let's hope this is now right. So that is 0.33. So let's go. So the probability Z, there Z is 0, there it is minus 0.33, and bigger than that. Okay, so what I will do is you can use the positive Z of 0.33, then it's just the other way around, but it will give us that bigger area. So 0.33, 0.33, it is 0.6293, 6293, or we could have said, let's get this area and then say 1 minus that area. So minus 0.33 minus 0.33, so 0.3707, 0.3707, that is that answer. But if you then subtract that, you again get 0.6293. Okay, so again, very important this to say more than, because if you said smaller than, you would have gotten the 0.3707. So there would have been an answer for you as well. Okay, so study unit 6, when we get closer to study unit 7, but still here, and this we've done a few times already where we needed to work this out, so not gonna look at this one. It's exactly the one that was also in your assignments this year. Huh. Okay, so I used this one exactly as in the assignment. It was in the previous assignments as well. So this one was nearly used a few times. Okay, so this one was, I can't remember this one from anyone. So, okay, so let's go into normally distributed population with a mean of that standard deviation. Okay, so standard deviation is known. So we work with Z. So your Z is when, and let's just fill in with things that we already know, is the mean of 190. We'll get the X. We've got the standard deviation of 120. We'll get the sample. So there's the sample of 50. Unfortunately, not a nice one that we can square root. And then what is the probability that the sample mean is at most? Sure. Okay, so at most, so again, good to have that table that we had. So at most is not more than, so 150 or less. So if we do a diagram, so just looking at, this will be 0, 150 minus 190 will be negative, and then it must be smaller than. So we're looking at this area. So automatically I can say this is going to be 0,5. So that area is going to be less than 0,5. So not A, not B, very unlikely that it's going to be C, just because if I look at where, if it is 0,4901, it is just smaller than 0. Okay, so let's work it out. So 150 minus 190 is minus 40. And then below the line, 120 divided by the square root of 50. So that is 16,9706. So that will then be equal to minus 2,357. Sorry for that. So that will be rounded off 2,36 minus 2,36 and the smaller area. So minus 2,36 minus 2,3. Oh, come on, where did we then have it as well in a previous? I can't remember this one at all. So minus 2,36 we're looking for. You guys want to make sure 2,36. Yeah. So 0,0091, 0,0091. Okay, so as you guys can see, I can't remember all of these, but now suddenly you see we have looked at it sometime this year in one of our exercises. So a lot of these actually do reappear. If you look at that one, reappeared. So there is a lot of these that somehow we actually did it some point in the year. I just definitely can't remember way back all of these. So if we do one where we have a population mean, then probably the next one is or proportion, or that we have the standard deviation as unknown. So let's see Okay, they talk about only 71% of schools. There's a sample of 99. Okay, so previous studies have shown that only 71% of schools have reported a decline in learners' absences since the start of the learner transport and the school nutrition program. Suppose a sample of 99 schools is drawn at random. What is the probability that at least 80%? Okay, so actually they don't mention here proportions, but this is population proportions, even though they don't mention it at all in this question. Quite interesting. So what we will need to work out is the Z with a proportion formula, and then we will need to go to the Z table, and at least, so at least means, phew, so if we, and that is going to be positive, so it means more than, so at least 5 means 5 or more. So at least means that whatever this is, it needs to be bigger or equal to. Okay, so in this formula, so here you guys could see that in this, it would be very crucial nearly to use that table that I have shared in a lot of the presentations where they talk about at least, at most, so that you can make 100% sure about the sign of the values, because you have seen in some of the previous ones, there is, for the opposite, there's also an answer. So let's quickly and use the calculator. So 0.8 minus 0.71, that we don't make a mistake in the numbers, and then 0.71 times 0.29 divided by 99, and the square root of that, I get 0.0446. So that means that your Z is bigger or equal to, okay, I get 1,9735. So that again, rounded off, will be 1,97. So if that is 1,97, I want that area. So go to the negative table, that gives you the minus 1,97. So that would help. 1, minus 1,9. Also, somehow we had it before, 0,0244. 0244. Okay, so somehow, again, we probably did it in one of our assignment preps. Okay, so that is the 1 minus 0,71. So remember, that formula is, if I just write the one beneath the line, so that is your that component. So the 1 minus 0,71 will give you the 0,29. Okay, so it is that component that we're working out. Okay, so that is for 0.29. Okay, so proportion, we had the mean, we still didn't have the standard deviation unknown. So let's quickly write that formula out that you guys can just see the formula. I think that will help in this one. So remember, when we look at proportion, the formula is, the proportion formula is this. And so that was our population that we want to work out is 0.8. That was out of all the previous studies with 0.71. So that's the population, that's the sample. And then we divide by the standard error, which is the 0.71. 1 minus 0.71 would give you the 0.29, and your N is that sample of 99 schools. And then if we work that out, we will get the 1.9735. So to use the table, we need to round that off. So we basically need to get the Z value of bigger than 1.97 for the probability. So if we look at the 1.97, because of symmetry, we could say that we can look just at the negative component, which is minus 1.97, and that gave us the 0.0244. So that is basically what we are all working out. Okay, so this one is to do with proportion, and then this formula is how we work out this Z for the proportion. Okay, so what was not in this mock exam is the one of where the standard deviation is unknown. So just take a note of that. So wasn't there in that one. This one we did last night, so it is in last night's recording. Just look at now, it's not last night's one we had N3, so now it is N4. So just again go and practice this one, and then you have last night's one to confirm. But I will then, well, you have the answer, but you can then use the methodology that we used last night to get to this one as well. So test this on the things that we chatted last night about, but just look. And again, important for your exam is just make sure that it might be, they say in the exam N2, so that you just just be aware that the numbering can change in that. Yes, there is a question. Is there a question? Okay, so let's let's continue. Let's see. Okay. Also, we've covered this one in last night's session. So I rather want to get to the ones that we haven't looked at, but here again, let's just quickly, by talking about population standard deviation. So that means that we can work with a Z over confidence interval for 95%. Because it's a Z, we can use 1,96. And then you use the normal confidence interval formula to work out the rest. So first identify the population standard deviation, if it is known or not. Here they tell us that we have a population standard deviation. So then you are allowed to say it's Z, and then because it's 95, we know it's 1,96. Okay, so this one we did cover last night. Okay, this one we also covered last night, but a bit different, and some of the answers a bit different. So last night I remember we said we needed to look for the correct one, and under the correct one there was an upper tail of t-test. So again, and we have here the population standard deviation is known. So we're working with a Z, but they're asking the incorrect one. So just again, be cognizant nearly of how they change the questions a bit, so that you don't in the exam where they might have similar questions, just be very careful about going for something that is in the mock exam and then they have changed it slightly. So just be nearly on the lookout for some of the things that have changed in the question. So I have shared this with you on the group as well. So here again, they say, and let's look at this one. It was, I think, slightly different in the other one. So consider a two-sided hypothesis test with a 5% level of significance and a 25 degrees of freedom. If a population standard deviation is unknown, what is the critical value? Okay, so unknown, we know we need to look for a t. So we look for a t where the degrees of freedom is 25 and where the level of significance is not 0,05, but remember it is 0,05 divided by 2. So that would be 0,025 and degrees of freedom 25. So it's a bit different to some of the other questions we had, because there we would have had an upper tail or a lower tail. So here it is two-sided. So two-sided means that we need to say that level of significance divided by 2. So we're looking at 0,025 and 25. So degrees of freedom, 25, and 0,025. So we have here 0,0595, 2,0595, 2,0595, so 2,0595. So if we round it off, we will get to the 2,06. And because it's two-sided, it means there is a positive and a negative one. Okay, so again, just important that we need to work with a T. That's also why they tell you degrees of freedom, because we need to work with a T. Okay, so this was a bit different to the one we covered last night. Calculate standard error of proportion. We did that last night as well. But again, just the formula for standard error of proportion is that part in the top that we divided by. So remember, if we now had the P minus the population proportion part, it would have been on the top. So the part at the bottom is again the standard error, but we have covered it last night as well. So again, standard error coming through, it might again be that most of the focus of the mock exams was on standard error of a proportion. So it might be that in the exam you get a standard error of the mean. So just again, if it's standard error of the mean, okay, so n is 60. So what would your pi be? Okay, so that would be 54 divided by 60. Remember, it's always a proportion, so x divided by n. So you have identified the two numbers, but remember, like you said, it's x divided by n. So your proportion will always be nearly a fraction. Okay, so, but right, so that would have been the 54 divided by 60. And then that one would be the 1 minus 54 divided by 60. So let's quickly work it out. 54 divided by 60. Oh yeah, okay, we did it last night because I can remember the 0.9. Okay, so it would have been at the top 0.9. Then it would have been 1 minus 0.9 would be equal to 0.1. That divided by n, which is 60, and the square root of that. Okay, so that is how you would have worked out this one. Okay, then if we have that, next one, hypothesis testing. And it was hypothesis testing with a proportion. So again, the things that you need to nearly look out for, it's one tail. Then to get the Z, we do exactly like we did up in the previous questions with this formula. Okay, so the last few questions, a lot of proportions coming through in this mock exam. So this would be just that formula that we would normally use. So we have P, they tell us that is 0.32. Our population one is 0.4. And then we will divide it by 0.4. 1 minus 0.4 is 0.6. Divided by n, which is 100. Then what we're also going to look at here, they tell us smaller, so we can already put that in there. So the p-value that we are going to look for, and if you look at that top, is going to be negative. So, and it's smaller, so it is, this will be the p-value that we are looking for. Yes, while I'm working this out, you can ask the question.
I would like to ask about the test statistic formula. Is it similar to this, or is it different?
The one that we did last night.
It's the one of the test statistic, yeah.
Oh,
That one,
so
yeah.
if we, yeah, so this is what we're working out is actually the test statistic. So that is actually what we are working out to get to the p-value is the test statistic. Yeah, so that is what we are working out. So you could have just looked at, oh, and here is actually how we would have worked it out. So there is our answer. So I'm just going to put it in here. So yeah, that is what we're working out. It is the t-stat basically, or the test statistic. So we want to get to that small area of minus 1,63. And that was probably the same as last night, but let's see, 1,6, no, it wasn't. Then it would have been here. Oi. So minus 1,63, so that's 0,0516, 0,0516. Okay, so basically what they haven't asked us to now in this hypothesis say we reject or not reject, so that we need to get the level of significance, and those things they don't even give us. So we basically only need to work out the t-stat. From there, work out your p-value, and then remember, also important, here it is smaller than. If it was not equal to, it would have been multiplied by 2, and then you would have gotten, so this would have been your two-tail answer if there was a two-tail, but we know that this is a one-tail because it's one directional, so that is why it is option B and not option C. So again, just it might be that now suddenly in the exam, very similar type of question, but then we go maybe to a question or where they say it's not equal to. So just again be on the lookout for the one tail versus the two tail. Yes.
I would like to clarify regarding the one tail and two tail, right? So the answer that we get from the Z statistic, right? We go to our our Z table, which is on page 120, 120 to
Yes.
121, right? And then the answer that we get is the 0,0516 because we had 1 minus 1,63 after the formula, right? So the one tail and two tail, is it the one tail is the value that we have on the table, and the two tail is when you multiply by 2.
Yes. Spot on.
Okay, thank you.
Spot on. So the two tail is basically the one tail times 2. Spot on. So that is perfect. Yeah. So what you get out of the table, the 0,0516, if you need to get it for the two tail, you basically multiply that by 2. Spot on. Okay, so let's see if this one. Okay, so this one was in last night's as well. Chi-square. We looked at 5 rows, 4 columns. So it was, I think it was just different numbers. So 5 minus 1, 4 minus 1, I think yes, last night's was 6 and 2 or 6 and 3 or 5 and 3 maybe. So 5 minus 1 is 4, 4 minus 1 is 3, so 4 times 3 is 12. Okay, so that is how we get to that one. So remember, the degrees of freedom is for chi-square is row minus 1, column minus 1. Okay, so that is, I think last night it was 4 of 5 and 3. Yes.
So I would like to ask, sorry to interrupt you. So this is again on the hypothesis test. I'm just trying to clarify something. So the value that we get right from our two tail and one tail, we can use it for making decisions whether
Yes.
we should accept the null hypothesis or we should accept the alternate hypothesis. So
Yes.
let's say, okay, so I see. In the pi is the proportion. Sometimes they use the mean also. I see.
See, so when so this one is the proportion, the other one with the mean and standard deviation, there we will compare it with the mean. But again, how you know it, what is important now is to test this against that. So, or if you get a critical value, or if I tell you you're testing against 5% or 10%. So also nearly important with this one is to see if you tested that against 5%, you would get a different answer than if you tested it against 10%. Okay, because that is bigger than 5%, so then you will make a different decision than that is smaller than 10%. So very important also when it is for one tail or two tail. If this was two tail and you test it against 10%, then that two tail number is 10.32%. So that then is actually bigger than the 10%. So also be very careful when they talk about the one tail and the two tail. When they give it to you in this, just make 100% sure the one tail or two tail, because it might have an influence what that one tail and two tail is on if you reject or not reject the null hypothesis as well. So just, and I think in a few of our examples that we have worked through for that study unit 9, we did some of those as well, where we needed to make a decision around the 5 and the 10%, and then which one works and not. So definitely that hypothesis one is important for you guys to look at in more detail as well, specifically with a confidence interval. Okay, I think this one we nearly discussed today a bit on the WhatsApp group. So let's just see if it is the same. So expected value of primary school learners traveling between 3 and 6. Okay, so there already there's differences, I think. And primary school. So that number is for observed. Remember, that's for observed. They ask, what is the expected frequency of primary school learners? So expected frequency is the total of primary school. So total of your row times the total of your column divided by n. Okay, so we don't have any of those, so we need to go and work that out. So the easiest one to add those to is 350. And so that we have the total of the column. The total of the row is 115 plus 210 plus 315. So that is 640. And then we need to divide it by n. So let's hope, I would have guessed it's 1,000, but probably not. Okay, it is 1,000. So divide by 1,000. So 640 times 350 divided by 1,000. It's 211.2. So if we round it off, it's 211. Okay, so definitely, okay, so the other ones, luckily, you can't really get to 1 to 2. So it might have been, if we work out that one, it might have been 1 to 2. 119 might have been that one. 2 to 1 is nearly, if you read 211 a bit wrong, then you get to 221. Okay, so that is how we would have worked out the expected value of that. So row times column divided by the n. And then the last one was this one that we actually have covered last night. So again, rather, and I now see they've changed it up a bit, the order of the things, but make sure you can work out the slope and the intercept, because they have not given you, they've given you the data, but they haven't given you any of the other things to work out those two numbers. So make sure that you are able to put this into Excel, or into your calculator. So again, if there's any guys of a 1510 that is watching, you will not get something like this, because you're not allowed to use Excel. So yeah, so that was the mock exam. So sure, that is it. Yeah, so um, I will share this now tonight as well, that I will share what we've done here, written out, that you guys get it. So I will share this with you, that you have it. And then I will also share the recording, and our WhatsApp group will still be open. So